Hi everyone, I'm Nexu, and today we're going deep on one of the most common but often misunderstood web vulnerabilities, IDOR, Insecure Direct Object Reference. Whether you're brand new to bug bounty hunting or pushing into advanced exploitation, by the end of this session you'll understand what IDOR is, how to find it, every practical technique from basic to advanced, the possible outcomes when you exploit one, and how to responsibly report and fix them. Modern web apps store objects, files, user profiles, invoices, images, messages, and each object usually has an identifier, a number, a file name, a UUID, or some token. When the application exposes those identifiers directly to users and doesn't check whether the requesting user is allowed to access that object, you have an IDOR. It's basically trust without verification. I have the ID, therefore I can access the object. Why IDOR matters? IDORs are dangerous because they break access control. They let an attacker access or manipulate data they shouldn't. In bug bounty terms, IDORs are juicy. They often lead to sensitive data exposure, account takeover escalation, or pivoting to other vulnerabilities. Imagine an API endpoint. Get/API/user/profile, ID equals 123, user A, request ID equals 123 and get back a profile. The app must ensure that ID equals 123 is actually mine. If it simply returns the record based on ID, that's an IDOR. As a speaker I might demonstrate like this. I'm logged in as Alice at example.com. I inspect a URL that returns my invoice/2019-0001. I change 2019 to 0001 2019 to 0002 in the URL. If I now see someone else's invoice, bam, IDOR. Simple mitigation check. Does the server confirm the session belongs to the requested object's owner? If not, it's vulnerable. How to find IDORs? Methodology. Start broad, surface discovery, crawl the app, look for endpoints that accept identifiers, query params, path segments, JSON bodies, multi-part forms, look at predictable IDs, sequential integers, 1, 2, 3, simple file names, timestamps. Predictability equals opportunity. Inspect client-side code, JavaScript, mobile apps, single-page app routers often reveal endpoints and parameter names, functionality to check, profile pages, order/invoice download, image/file access, message retrieval, admin pages, password reset tokens, membership IDs, document viewers, attachments, API endpoints that list or fetch resources, concrete techniques, manual parameter tampering, change ID values in UI/API calls, forceful browsing, try path changes on endpoints, e.g., /files/12345/files/12346, parameter pollution. Send both ID equals 123 ID equals 124 and see which wins. JSON body tampering. Change user_ID 123 to user_ID 124 in API post/put requests. Direct file access. If a file is at /upload/avatars/123.jpg, try /upload/avatars/124.jpg, ID enumeration, script sequential requests to map which IDs exist and note responses and content lengths, where to look specifically, profile pages and avatars, invoice/download endpoints, message viewing APIs, attachment download URLs, image/CDN object URLs, API endpoints listed in the WebApps.js or mobile app API docs, admin or moderator features that accept object IDs, expected responses and detection signs. When you tamper with an ID, the server's response gives clues. Full content returned indicates likely IDOR. 403 forbidden. Good sign server is enforcing access control. 404 not found may mean the app hides existence, sometimes indistinguishable from unauthorized. 200 but partial data. Sometimes servers redact some fields. Still often a vulnerability. Different content length. If you see content differences when testing many IDs, that indicates different objects exist. Timing differences. For large files or DB-heavy endpoints, timing can show existence. Always validate by comparing content, headers, metadata, and behavior rather than just HTTP status alone. Part 4. Advanced Techniques and Bypasses. This is where things get powerful. 1. ID guessing/enumeration at scale. If IDs are sequential integers, write a script to iterate and request many IDs, add rate limiting and back off to avoid lockouts. use response fingerprinting, length, certain keywords, to identify valid objects. Combine with word lists for non-numeric IDs, file names, GUIDs. 2. Parameter aliasing in alternate fields. Some apps accept the same object via multiple parameter names, ID, user ID, resource_ID. Try all discovered param names. Try sending the ID in headers, cookies, or both. Some load balancers or middleware read different places. 3. Type confusion. If an app expects an integer and you send a different type string, JSON object, sometimes server-side code fails over to a default or different lookup logic that leaks objects. Try ID equals 0001, ID equals 01, ID equals 123, or ID equals 123, null byte, to trigger different parser behavior. 4. UUID/GUID partial matching. If the system uses UUIDs and you know one, try truncating or mixing parts. Some databases or APIs perform prefix searches. 5. Combining auth flaws or logic bugs. Use IDOR with CSRF. If a victim is authenticated, trick them to perform an action that changes a resource ID mapping and then retrieve it. 7. Predictable object mapping. Many apps map objects as concatenation of user ID resource ID, user_123_file_456. If you know user ID patterns you can craft requests. 8. Mass exploitation. Be cautious, ethical, if permitted. In scope Bugbounty program, you can enumerate many IDs to assess scale of exposure. Always follow program rules and rate limits. 9. Access control pivot. Some IDORs reveal internal IDs or system paths that lead to admin-only endpoints. Use that information to find further flaws. 10. API-specific tricks. For GraphQL, try changing ID fields in queries or using fragments to access other nodes. Possible outcomes when exploiting an IDOR: read sensitive PI, names, emails, SSNs, addresses, access financial info, invoices, payment methods, transaction histories, modify resources, change ownership of an object, edit another user's profile if right endpoints are vulnerable, account takeover. Sometimes IDORs let you reset or retrieve password reset tokens, or swap email addresses via ID changes, expose thousands of records, privilege escalation, access to admin resources if they're keyed by identifiers. Always document severity using impact, sensitive data exposed, account takeover risk, and exploitability. Requires authentication. How to responsibly test and report. Important rules. Always follow scope. If you're on a bug bounty program, only test in-scope endpoints. Don't exfiltrate more data than necessary. For POC, a small sample is enough. Avoid downloading entire databases. Rate limit your tests. Avoid DOS or account lockouts. Follow disclosure policy of the program and include clear remediation guidance. What to include in a report, steps to reproduce, proof, request/response pairs, screenshots, impact statement, what data can be accessed, how many users potentially affected, severity suggestion, suggested fixes. Final tips: ethical notes. Start testing where users interact with objects, upload/download, wallets, invoices, messages, profiles. Use both manual and automated methods. Automation speeds enumeration, manual logic analysis finds the tricky ones. Combine IDOR checks with other vulnerabilities, logic flaws, CSRF, but always respect rules and ethics. When reporting, be clear and helpful, include remediation steps and an assessment of impact. Finally, remember, a vulnerability is only a risk if there's sensitive data or function behind it. And that wraps up our deep dive into IDOR vulnerabilities. From the basics of what they are, to identifying them, exploiting them responsibly, chaining them with advanced techniques, and understanding how developers can shut them down for good. If you've followed along till now, you're already ahead of most beginners, because IDOR isn't just a change the ID and see what happens trick. It's a mindset, understanding how objects are stored, how authorization is, or isn't, enforced, and how tiny logic flaws can open massive security gaps. Remember, always test ethically, always stay within scope, and always report with clarity and responsibility. The goal isn't just to find bugs, it's to make the internet safer while sharpening your skills and earning rewards for solid research. Thanks for sticking with me through this session. Keep hunting, keep learning, and as always, hack responsibly.